This study encompasses the characterization of 3 samples from the colonial ranch of Macuilapa, located in Cintalapa, Chiapas, as shown in Figure 1. 2 adobes from different periods, 16th and 19th century, along with a mortar sample, are analyzed. The primary aim of the research is to study some macroscopic features to relate them with the elemental and mineralogical composition. The research aims to evaluate if the proposed methodology is optimal to fully characterize these composite materials. Samples A1 and A3 were obtained from the indigo factory, shown in Figure 2A. On the other hand, sample A2 has been obtained from the adobes that were reused to carry out the restoration of the Virgen de Dolores Chapel in Figure 2B. The proposed methodology starts with the study of their particle size distribution to identify technological differences, and then each granulometric fraction was observed with a stereoscopic microscope. The type of clay and fillers used were classified according to the Unified Soil Classification System. Then, X-ray fluorescence and scanning electron microscope with energy dispersive spectroscopy were performed for elemental identification and to evaluate morphological characteristics. The color and behavior of the clay fraction was linked to the crystalline phases present, and it was possible to identify other amorphous phases such as goethite and hematite using diffuse reflectance spectroscopy and the Kubel-Kammung theory. The photoluminescence spectrum of one of the samples was also studied as a preliminary analysis to observe the emission of light produced by some minerals present. According to the granulometric study, the adobe in the chapel contained significantly more straw than the adobe in the factory. Contemporary earthen architecture is usually made with adobe formulations consisting of 5 to 30% clay, 20 to 40% sand, and the remaining silt, which aligns with the composition of adobes shown in Figure 4. The plasticity graph in Figure 6 shows that both soils are inorganic lean clays. Therefore, these soils are considered suitable for construction, as it is generally accepted that soils for earth construction fall into the range of inorganic clays of medium plasticity. Figure 7 shows the stereoscopic microscopy images of the different granulometric fractions. It is observed that in the coarsest fraction, there is also fine material. The clay fraction retained in the number 200 sieve is arranged in bundles of oriented crystals, and these domains are bound to larger particles. The color of the samples was measured with a colorimeter, and these coordinates were plotted in a chromaticity diagram. The reddish color of the adobes may be associated with the presence of hematite or goethite. For the mortar, the color is lighter, possibly due to the addition of lime as a stabilizer. The analysis of the chemical elements with X-ray fluorescence facilitated the identification of the mineralogical phases with X-ray diffraction. The geological context of the area can be an important guide to identify the origin of the raw material. In this case, cambisol is a reddish soil with a high content of iron oxides and clays. X-ray diffraction results shown in Table 1 indicate that the predominant material for samples is quartz, accompanied by feldspars, as expected in a sandy material. Sample A3 has a high content of calcite, which is consistent with the XRF and SEM results. The presence of kaolinite and montmorillonite was also observed. Using the Kubel-Kammung theory, we can estimate the presence of iron oxides. In this case, it is proposed that the coloration of the samples depends on the content of hematite and goethite, which may not necessarily be in their crystalline phase. Additionally, preliminary photoluminescence analysis detected the presence of titanium dioxide and confirmed the existence of silicon dioxide and aluminum oxide. The proposed analyses complement each other, and it was possible to relate the chemical and mineralogical compositions with some physical properties of the samples. Analyzing these materials forms the fundamental groundwork for any forthcoming intervention projects in the construction environment. Moreover, studying these ancient sustainable construction materials may be the key to making current adobes that are safe and efficient to meet housing demands.